Let g of x be equal to x plus 3 when x is less than 1, 2 when x is equal to 0, and 3x minus 4 when x is greater than 1. Sketch the graph of g of x. Well, to be able to sketch this one, we know the critical point that we are talking about here for x, that is a 1. So even as we get to work out, we need to pay attention to 1, right? So here we have got x values, and then there we have got y values. So we have got x being equal to 1 at this point. So what I'm going to do is, when x is equal to 1, I'll go in this function and put there, that to be 1 plus 3, that is going to give us a 4. Now we can clearly see that we are not including 1, therefore at this point I'm going to put an open circle. And then we're interested in values of x less than 1, so I'm going to get a 0 put here. That is going to give us a 3. So 3 somewhere there, so it's 0 comma 3. And then when we use negative 1, we put in the function, we're going to get 2. So it will be somewhere here if that is 2. Okay, to continue going like that, and that is a straight line, so I can just join these coordinates. So the line will go something like that. And then when x is equal to 1, the y value we're going to find is a 2. So that is 1 comma 2, and 2 is somewhere here. So this is the point here. And for x is greater than 1, the equation that we are using is this one. So where there is x, I'm going to put 1. So it will be 3 multiplied by 1 minus 4, that is a negative 1. So negative 1 is going to be somewhere here. So that is 1 comma negative 1, which is a coordinate here, and is going to be open because we're not including 1. And then since this one is value for x is greater than 1, so we go to 2. When x is 2, that will be 3 times 2, which is 6, minus 4, that is a positive 2. Okay. So positive 2 is there, so the line that is telling us that is going to come and pass. Let me just do that again. When we got 1, we put here 3 multiplied by 1. That gave us 3 minus 4, negative 1. So that was 1 comma negative 1, which is the point there. And then when we get to put there 2, we are finding a 4. Okay. I mean a 2. Since this 2 here, 3 times 2, that is going to give us 6 minus 4, that is a 2. So that is 2 comma 2, which is somewhere here. So 2 coordinates are enough for a straight line, and then we get to join these. Okay, that is going to go something like that. So this is a graph of this function. And then the next one, find the limit as x approaches 0 of f of x. So limit as x approaches 0. So which one do we think is going to include 0 for this question? So this one is talking about values of x greater than 1, and obviously 0 is not greater than 1. This one is talking about values of x less than 1. That is where 0 is going to be found. So to find that limit, we are going to use this equation, which is here. So that is going to become, where there is x, we're going to put, so we're going to say limit as x approaches 0 of x plus 3. That would be the f of x we are going to use. So that is going to give us 0 plus 3, which is a 3. So this is the value that we are approaching as we approach 0. And then the next one, justify. State with justification whether g of x is continuous at x is equal to 1. First thing first, we need to find f of 1. Now we've seen that when we get in the function, we put x. The value of y that we are getting is a 2. So that is f of 1. Then the next thing that we need to find is the limit. Okay, so we find limit as x approaches the same 1 from the negative side for the function f of x. So we're going to go to these functions, these three functions which we have. Which one is talking about values of x less than 1? That is because we're approaching from the negative side. So that is the first one. So that is going to be, where there is x, we put 1 plus 3. That is going to give us a 4. And then the next one, we need to determine the limit as x approaches 1 from the positive side of f of x. So in this case, what we're looking for is the function that has got values of x greater than 1, which is this one. So that is going to become 3 multiplied by 1 minus 4, and that is a negative 1. Now clearly we can see that limit as x approaches 1 from the negative for f of, this is actually g of x. So we are used to f of x, that's why I'm writing f of x. Alright, so this is g of x. So the limit as x approaches 1 from the negative of g of x is not equal to the limit as x approaches 1 from the positive of g of x. What does this mean? This means that the limit as x approaches 1 for g of x does not exist. So if the limit does not exist, the last condition to show that something is continuous is that f of 1 should be equal to the limit as x approaches 1 for g of x. And here I'm also saying f, this is g of 1. Now we know that g of 1 is 2, and then the limit as x approaches 1 does not exist, so these are not equal. So since g of 1 is not equal to the limit as x approaches 1, then the function is discontinuous at x is equal to 1, or is not continuous at x is equal to 1. We can even see that it's not continuous because it's hard to cut.